Before I get to the still controversial story of the Navy's F-111B fleet interceptor, I think it's important to first reflect on the nature of the mission it was intended to perform. And that starts with a brief review of how the threat to US fleets evolved from the 1940s into the 1960s. The threat to US carrier battle groups in 1941 and 42 was from an enemy with a roughly equivalent disposition of large aircraft carriers and escorts. Attacks consisted of waves of torpedo and dive bombers from a close range. The maximum realistic drop distance for a torpedo bomber in 1942 was around 1,000 yards. By 1944 and 45, the threat had evolved to include kamikaze aircraft and radio-directed bombs. Both are rudimentary forms of guided projectile, but fortunately both were limited by the comparatively slow speed of their delivery platforms. The post-war enemy was the Soviet Union, which had no blue water navy of note. The threat was therefore restricted to a few hundred miles off the coastline of the Soviet Union or its allies. Although the Soviets certainly had torpedo bombers and a large force of level and dive bombers, their experience in maritime surveillance was not even really comparable to the Italian Navy, let alone the German or Japanese. Their aircraft were piston engine types and very vulnerable to US Navy Bearcats and Corsairs. The real danger to US carriers was therefore minimal. The first real change in this situation came with the introduction of the Beagle light bomber in the early 1950s. Jet-powered with a maximum speed of about 550 miles an hour at sea level, Soviet Navy versions of the IL-28 could carry two airdrop torpedoes or 1,000-pound bombs. If they were able to penetrate the carrier's combat air patrol, then they would be very difficult to shoot down with World War II-era guns, whether they were radar-directed or not. Because their maximum speed was only 20 miles an hour slower than that of the Grumman Panthers and McDonnell Banshees that made up the combat air patrol, they would be very hard to stop further out as well. If the carriers were closer into shore, then even a MiG-17 carrying 250-pound bombs could seriously impact a carrier's combat effectiveness. The US Navy had already anticipated these challenges and were studying guided missiles with sufficient speed and range to nullify the attacker's modest speed advantage. The Sidewinder and Sparrow came from opposite ends of the complexity spectrum. Sidewinder was an elegantly austere weapon. It was relatively reliable and required minimal avionics in the firing aircraft. But it was only effective at ranges of a mile or so in chase, and it was only able to home on a target when fired from a narrow cone in the rear quarter. Sparrow was in effect a small aircraft, weighing 400 pounds in its early configurations. Beam riding, active and semi-active homing variants were in development by the middle 1950s. Sparrow was a very complicated weapon right on the cutting edge of technology. Early beam riders were effectively line-of-sight weapons. The active versions didn't work, and the semi-active versions would turn out to be unreliable at the best of times. The semi-active radar homing Sparrows homed on reflected signals from the firing aircraft's radar coming back off the target. If the system worked well, then the Sparrow could be launched from all aspects at ranges up to 15 miles. At motor burnout, it would be travelling at Mach 4 or so, and it carried a large warhead with high lethality. Even putting aside the poor reliability of the majority of parts of the Sparrow weapon system and the effects of ECM on its performance, the firing aircraft could only engage one target at a time. By the time the first workable Sparrows were available to the carrier air group, the threat had grown significantly. First, nuclear free-fall bombs began to be made available to Soviet naval aviation. This greatly increased the lethality of a wave attack. Only one bomber had to get through. Then the bombers themselves became more effective with the service entry of the Tu-16 Badger. By the middle 1950s, the Badger was seen flying with AS-1 Comet cruise missiles. Weighing over 6,000 pounds and travelling at subsonic speeds, the Comet was very crude, but it could travel up to 60 miles from the launching aircraft, and being smaller than a contemporary jet fighter, represented a tough target. Armed with a nuclear warhead, it further emphasized the need for long-range, accurate guided missiles. Because the Comet's range was modest, it was eminently feasible for the Navy's latest interceptor, the F-4 Phantom, to get out amongst the bombers well before they reached a position to launch. But via intelligence sources and basic common sense, the Navy knew that the Soviets were working on faster missiles with longer range. The AS-5 Kelt would eventually enter limited service with Soviet naval aviation in 1962. Its range was 120 miles, and the missile itself was just about supersonic. One additional advantage that the Kelt brought in was the ability to be launched from 500 feet of altitude, which could be advantageous if the Badgers were able to close inside of 120 miles. Higher launch altitudes obviously improved range at the cost of defensive awareness. There was also the much more dangerous AS-2 Kipper. A Badger could carry one of these nearly 10,000-pound missiles, but the Kipper travelled at Mach 1.3 and it had a range of over 200 miles. One way or another, the speed of the Phantom was no longer enough to guarantee that the carrier's interceptors could reach a position to attack Badgers before the bombers were able to launch their anti-ship missiles. Something new was required. From an aircraft design perspective, this meant playing with several parameters in order to achieve the required combination of engagement distance from the carrier and probability of kill. Setting aside satellite and other forms of reconnaissance to provide raid warning, achieving a sufficiently remote engagement distance started with the carrier's airborne early warning assets. A history of these aircraft would more than double the length of this video, but in the late 1950s, suffice to say the state of the art was the Grumman E-1 Tracer, although its replacement, the iconic E-2 Hawkeye, was already in the works. If early warning assets were able to detect an incoming raid at, say, 300 miles from the battle group, then the next task was to get interceptors into a position to engage. In the traditional fleet defense model, a combat air patrol would be aloft, and if they had sufficient fuel, they would be directed to engage. But the cap was not a sufficiently strong force to deter a raid by a regiment of Soviet naval bombers, which could be between 40 and 60 aircraft, depending on the type and the era. More interceptors would thus be required. Traditionally, these would be catapulted as the threat evolved and would move out from the fleet as fast as possible to reach a firing position. This was the rationale behind the very powerful F-4 Phantom, which was comfortably able to break Mach 2 in a dash. If we scale back to a more realistic Mach 1.5, then a Phantom covers a third of a mile every second. But you can probably start to identify the problem. Even if they remained subsonic, the Badgers are covering about 0.2 of a mile in a second. Unopposed, they would reach a launch position in about 20 minutes. That is not a lot of time to get enough Phantoms out to intercept, given that the carrier can only launch a maximum of 4 at a time, and given deck handling constraints, probably can only cycle another one a minute thereafter. Given that the Phantom could realistically only engage one Badger in a head-on attack, the mathematics, or perhaps the economics, of the engagement are stacked against the defenders. This is, of course, quite a pessimistic scenario in which there is limited warning. The Soviets have succeeded in accurately locating the battle group, and we're only talking about one carrier, albeit a Forrestal or later supercarrier. It is still that little bit too close to call, though. The Navy's conceptual solution to the puzzle was to create an aircraft that was able to loiter hundreds of miles away from the carrier so that it didn't have to worry about the speed at which it could launch and then race to an intercept point. It will be armed with a new generation of air-to-air missiles. Just as the Soviets were employing cruise missiles with extended range, high speed, and autonomous targeting capabilities, so the Navy would arm its interceptors with the air-to-air missile equivalent. That missile was the Bendix Corporation's Eagle, which weighed nearly 1,300 pounds and had a range of 100 miles. Employing these weapons would mean mounting the most powerful radar yet fitted to a fighter-type aircraft. The loitering missile aircraft was called the F-60 Missileer, and it would have carried 6 Eagles on missions lasting as long as 6 hours. The Missileer had absolutely risible dynamic capabilities. It was basically a transport aircraft. The argument was that it simply didn't need any of that, as it was in effect just an extension of the battle group's surface-to-air defenses rather than a fighter or an interceptor in the traditional sense. Even though there were doubts about acquiring such an unsurvivable platform, for the Navy, the Missileer and Eagle program that began in 1958 and was formalized into a specification in 1959 was the jumping off point to the F-111 debacle. Program. In the late 1950s, the US Air Force's Tactical Air Command was also in the early days of procuring a new aircraft platform. Their problem was quite different to the Navy's, but was also caused by advancements in Soviet aircraft and missiles. The F-105 was by far the TAC's favourite toy at this time. It was sensationally fast at low levels and could shift a heavy load of bombs. Although there are those who say that the Thud was a good air-to-air fighter, their evidence base relates to victories against the obsolete MiG-17 flown by inexperienced pilots. Its air-to-air capabilities against a modern, properly trained opponent were extremely limited, and its interception capabilities were essentially non-existent. The nuclear strike-centric Air Force referred to it as a fighter in the same way as the Navy referred to the Missileer as a fighter. Two more divergent definitions of the term are probably hard to find. The Air Force wanted a Thud replacement strike aircraft that could operate from short, unprepared strips in all weathers. It needed a combat radius of 900 miles on internal fuel and the ability to dash at Mach 1.2 at low level for 400 miles. The Navy's requirements would change throughout the program, as I'll get into in a bit. But for reference, when the Navy accepted the Missileer as their fleet interceptor, it was going to have a launch weight of 60,000 pounds, a 70-foot wingspan, and it was 53 feet long. The operational requirement was to stand off 150 miles from the carrier with a loiter time of 10 hours at 35,000 feet. For this reason, it was powered by new and efficient TF30 turbofan engines, which would carry over into the eventual TFX. In truth, the only similarities between the two services' requirements were the large weights of the aircraft concerned and the need for two crewmen. Otherwise, they appear to be totally different. 1961 brought JFK to the White House and Robert McNamara into office as Secretary of Defense. One of the latter's main bugbears was with military procurement, which he saw as very inefficient. Having sorted out designation systems and forced the Air Force to buy the F-4 Phantom, he then decided that the TFX and the Navy's Future Interceptor program should be brought together into a single set of requirements and a single common platform. Initially, he also wanted air support in the brief, but sensibly this was split out and became the very successful A-7 Corsair II. That program was managed by the Navy. The essential technology behind the new fighter was the variable geometry wing. Testing of this idea had occurred in the late 1940s and early 1950s at Bell and Grumman, but the wing mechanism proved to be rather bulky because of the need for the central hinge to translate backwards and forwards as the wings moved. The NACA continued to work on the idea and perfected it by the late 1950s. In combination with the new turbofan engine, it was believed that an unusual combination of performance features could be packed into one aircraft. There then followed a tortuous set of negotiations on specifications, during which a strange thing happened. For once, it was the Navy that acted like the spoiled kids and the Air Force that behaved like responsible adults. With the benefits of hindsight, it was obvious that the Navy didn't want a TFX-based fighter, and it had therefore decided to make things impossibly hard for anybody foolhardy enough to respond to the eventual brief. Initially, they said they wanted a fighter that was no more than 50,000 pounds loaded and under 56 feet in length. This was plainly unreasonable. The Missileer, which lacked almost all of the dynamic abilities of the TFX, would have weighed 10,000 pounds more than that and would have taken up more deck space because of the way its wings folded. The F-4 had less than half of the loiter time and carried Sparrows, 4 of which weighed roughly the same as one of their proposed Eagle-type missiles. And in cap configuration, the F-4 weighed 54,000 pounds. You'll be getting the idea, so I won't labour the point. As the General Dynamics executive later remarked, looking back through these requirements, we see small size, large load carrying capacity, rugged strength, light weight, sophistication and simplicity all wrapped into one. It's a little like looking for a Volkswagen with Ferrari performance, Rolls-Royce appointments, and Mack truck carrying capability. On the 6th of December 1961, a set of capabilities were agreed and 6 companies responded. The selection was as tortuous as the specification development had been. After 4 rounds, in which none of the potential vendors had met the requirements, the only 2 left in the competition were Boeing and General Dynamics, who had partnered with Grumman. Eventually, in November 1962, the Air Force and Navy Assessment Committee reached a unanimous decision, and they selected Boeing as the winner and constructor of the TFX for the Navy and the Air Force. And yes, you did hear that right. The fly in the ointment was, you guessed it, Robert McNamara. As a former Ford executive, he looked at the 2 products with a rather different lens. The first thing he spotted was that the General Dynamics proposal had actually scored higher than the Boeing one across all of the metrics being considered. Secondly, he was not deceived by the Boeing promise of commonality between the 2 services aircraft. Boeing was only able to offer 60% commonality by parts and 40% by weight, against 80% in parts and 90% in weight on the General Dynamics aircraft. Finally, the Boeing design assumed significant developments in US industry's ability to work with titanium, which was used in the vital wing carry-through structure. His assumption was that Boeing was intending to pass a lot of additional development costs onto the services in order to present a cheaper price initially. Using older, stronger materials also suggested that the General Dynamics product would have a longer service life. So McNamara reversed the decision and awarded the contract to General Dynamics. Boeing inevitably didn't like this and appealed, resulting in a Senate subcommittee being set up to investigate the whole affair. Boeing went first, explaining the thousands of hours of wind tunnel tests they'd performed and all of the clever calculations they'd made. It was all terribly impressive. And then General Dynamics turned up. Actually, that's not strictly true. What actually happened was that General Dynamics told the subcommittee that they'd done lots of testing as well, but if you really wanted to know why their proposal was better, you should talk to this guy. This guy was legendary Grumman test pilot Corky Meyer, and he had performed 300 takeoffs and dozens of flights in the Grumman Jaguar, the only swing-wing aircraft to get even close to production in the US prior to TFX. Quite why no one had thought to look at the team's experiences a little bit more closely until this moment is a bit of a mystery. Neither Boeing nor General Dynamics had any practical experience in swing-wing fighters. The sum total of their knowledge of how to build a carrier-based jet fighter was 0. In fact, neither of them had much in the way of fighter experience of any kind, full stop. Grumman Aircraft, on the other hand, had by this point made 50% of all US carrier launches. They had been building Navy fighters since the 1930s, and their aircraft had scored the vast majority of air-to-air kills scored by the US Navy in World War II. The Senate therefore upheld McNamara's decision, and the very cool-looking Boeing TFX was consigned to history. Sadly, the road ahead was still rocky. As I've said already, the F-111B design team had to thread a line between multiple competing requirements, and that's just talking about the Navy version. The entire point of the aircraft was to take a powerful radar system and heavy Phoenix missiles out to a point at which it could intercept waves of Soviet bombers. In a way, the entire protracted design effort and countless billions in tooling, production, and maintenance costs would come down to 1 or 2 engagements in total. No one else had fleets of missile-armed bombers. The Navy had originally wanted a radar with a 48-inch dish to give them the desired power and range, but they were forced to compromise at 36 inches, which was still pretty big. The radar attached to it was the ANAWG-9. The AWG-9 was a Hughes product, descended from a US Air Force project to develop a Mach 3 interceptor called the F-108 Rapier. Rapier used a combination of an ANASG-18 radar and advanced AIM-47 Falcon missiles. These were less ambitious than the original Missileer and Eagle specifications, but they were more technically realistic and they were more developed. With a great deal more development, this would eventually become the AWG-9 and the Falcon would be developed into the Phoenix. The F-111 was designed to carry 6 Phoenixes, each weighing around 1,000 pounds. 4 were on swiveling underwing pylons, and the other 2 were in the internal weapons bay and the fuselage. There was provision for an internal cannon, but this was never fitted. As in the Phantom, the Navy was at this point fully committed to missiles. Despite the large radar installation, the F-111B's nose was shorter than that in the F-111A. Keeping the length down meant that the aircraft could be kept in the small space of the deck and the hangar of a Midway-class carrier, and inevitably it was another one of the running battles that the Navy was going to fight through the program. There was also an infrared search and track system under the nose, which was fitted to the last prototypes. The variable sweep wing could move between 16 degrees when fully forward to 72.5 degrees when it was fully back. Wingspan in the forward position was 70 feet, which was longer than on the F-111A because of the high altitude loiter requirement. Fully swept back, the span was just 33 feet and 11 inches. There were 6 underwing pylons, but only the inner 4 swiveled. The outer 2 were for drop tanks, and they were pointed forward at 26 degrees of sweep. When wing tanks were being carried, the wing was restricted to that 26 degrees. To further enhance low-speed handling, the wing had full-span flaps and slats. The horizontal stabilizers were quite large, and they moved together for pitch control and differentially for roll control. You'll probably notice that when the wings are back, the wing tail and the broad fuselage form a single lifting surface. The F-111 was one of the first aircraft to employ this idea, which is obviously commonplace today. 50% of the aircraft's lift was generated by the fuselage, which leads to slightly unusual stalling characteristics. The F-111 doesn't really stall as such. Rather, it yaw diverges, making it essentially impossible to recover from a spin caused by flying into this regime. The single tail also created some issues for an aircraft that may at some point have been expected to engage in fighter maneuvers. Fuselage blanking of the rudder would occur at a 25-degree angle of attack, causing a loss of directional stability. In practice, the safe zone for angle of attack was between 18 and 20 degrees, which isn't all that useful if you're trying to point the nose at something. From an aerodynamic standpoint, the F-111 was designed for very high speed in a straight line and a high level of stability on landing. Agile, it was not. Another innovation that the Navy insisted on was the provision of an escape pod for the pilot and radar operator. The escape pod is an ingenious concept designed to improve crew survival, particularly in the event of high-speed ejection or landing in water. During testing, 2 Air Force technical sergeants spent 24 hours floating in the sea in the escape pod off Kodiak Island in Alaska. Apparently it was a bit cold, but they survived in a sea that would have killed an unprotected person in a matter of minutes. The downside was the 3,000-pound weight of the system, which was roughly 10 times that of a pair of ejection seats. Given that weight was probably the F-111B's fundamental issue at this stage, one could uncharitably suggest that the Navy's insistence on the system was part of their overall campaign against the aircraft. The Air Force would have just been fine with seats. Another Navy requirement was the side-by-side seating arrangement, which was intended to improve visibility over the nose and to the left of the pilot on approach. Side-by-side also kept the length of the aircraft down somewhat, which was also useful. The A6 Intruder had this feature, as did the A3 Sky Warrior, but the 70-plus foot long A5 Vigilante didn't have it, nor did the F4 or ultimately the F-14. The cost of the arrangement was a wider fuselage and almost certainly more weight through increased volume. In the case of the F-111, that volume was useful as it allowed the carriage of more fuel, which was needed to accomplish the range and loiter time requirements. Power to lift all this kit came from an afterburning version of the Pratt & Whitney TF-30. The F-111 was the first fighter to use a turbofan power plant, which offered significantly greater efficiency in exchange for reduced top-end power and greater susceptibility to compressor stalls when maneuvering. In the initial F-111B, those engines provided 10,750 pounds each dry and 18,500 pounds in afterburner. The afterburner installation was also the first of its kind to be able to be modulated rather than simply being on or off. The compressor stalling problems, on top of the angle of attack restrictions, further reduced the F-111's potential to take on other fighters. It was, however, markedly superior in that respect to the lumbering subsonic Missileer. Landing gear was already well specified because of the Air Force's requirement for rough field operations. The Navy bulked it up a bit further, but they also reduced the size and strength of the tyres as it would be landing on a carrier deck. Catapult bridles were fitted on the nose gear and a strengthened arrestor hook at the back. After much toing and froing, the first prototypes were 66 foot 9 inches long and they weighed about 66,000 pounds in cap configuration. In 1965, they were ready to start testing. F-111B was about 6 months behind the A. The first example flew on the 18th of May 1965. It and the next two aircraft were some distance away from the final production configuration. As well as being shorter in the fuselage and using the shorter Air Force wing, it lacked the crew escape module and it had a basic engine arrangement. Avionics fit-out differed considerably as Hughes carried on with the painful development of radar computers and the Phoenix. Even so, the early aircraft would carry out a great deal of the testing. Although it would be fair to say that they demonstrated some fairly thorny issues with the F-111B, there was nothing that was out of the ordinary for a very advanced aircraft that incorporated numerous new technologies in one package. Probably the most challenging single issue to be solved in testing was the engine. Although it had been in development since the late 1950s, the TF-30 actually only flew for the first time a few months before the F-111A's first flight in December 1964. That was in the A7 and it was in non-afterburning form. The main issue in the F-111 was the intake. At supersonic speeds, an intake doesn't need to be very large as air is being forced into it. As long as the air can be slowed down to a consistent subsonic speed across the area of the intake as it enters the engine, then things will be fine. At low speed, high thrust requires a large intake with the right shape to scoop up as much air as possible. To deal with both of these flight regimes, the original F-111 intake consisted of a moving intake spike to control the speed of the air, and a translating cowl that expanded the intake area at low speed. This design met the specifications that General Dynamics and Pratt & Whitney had agreed was required. It was only when the prototype started flying that they realized the true needs of a turbo fan versus previous turbojets, and the flaws in the design of the engine itself. The early aircraft suffered from compressor stalls at high speeds and altitudes and when maneuvering at all speeds. Incidentally, it's probably lucky that the Boeing design with its above-the-fuselage intakes was not selected, as it's likely those issues would have been unfixable due to the way the fuselage masks the intakes when the nose is high. Fixing the issue was not easy at all, and it required both development of the intake and of the engine to make it more stall resistant. The first airframe modification was called Triple Plow 1. It moved the F4 style splitter plate outboard by 4 inches and added vortex generators within the intake. Since I haven't mentioned them yet, the splitter plates were there to keep boundary layer air from going into the intakes. Triple Plow 1 moved the compressor stall at speed out beyond Mach 2 and it would be used on the first production F-111As. There'd be more intake development later as production of different versions of the F-111 continued over time. Top speed testing would reveal that the A and B models were capable of Mach 2.5 at altitude with the Triple Plow 1 intake. The F-111 would prove to have no aerodynamic speed limit as such, but rather a temperature limit. For weight-saving purposes, the wings and structure were aluminium honeycomb, not steel or titanium. The wing leading edges were thus only rated to withstand 150 degrees Celsius of temperature for 5 minutes. Allegedly, the F model, which had 40% more thrust than the A, could do Mach 3. This was very much not allowed, though, as it caused significant damage to the aircraft's structure. I've heard the story about that Mach 3 speed in interviews with experienced F-111 pilots, so it might actually be true. One way or another, the F-111B was very fast, even compared to later Teen Series fighters or the F-106. Engine issues aside, for the Navy, the big sticking point that eventually was to kill the program was weight. All aircraft development programs begin with a promise from the supplier about weight, and they end with something a lot higher. The F-111B was no different in that regard. Boeing's submission had tried to get around that problem through the use of advanced materials, but their use came at a price in terms of technology risk, likely program costs, and overall durability. For the Air Force, weight was only really an issue in terms of the last 5 or 10% of aircraft performance. A bit of drift was tolerable. but the Navy had fundamental limits that could not really be exceeded because of the need to operate from their aircraft carriers. Essentially, there was a maximum weight that could be accelerated by the steam catapults, stopped by the arresting wires, and lifted from the hangar by the elevators. These limits could be moulded a little by restricting the F-111B to certain types of carriers, but early on the Navy had said that the aircraft should be deployable on the Midway and later carriers, just not on the older Essex ships. In the case of the F-111B, the Navy needed an aircraft that could be catapulted with maximum fuel and 6 Phoenixes, and then come back aboard still carrying those missiles and enough fuel to provide a safety margin. It also needed to be safe to handle behind the ship with one engine out. Ideally, it could be fueled and armed in the hangar and brought up rather than doing all of that on the deck, and it would be light enough to take off with a normal amount of wind over the deck. When the final specification was reached, the Navy had adjusted its wholly unrealistic £50,000 takeoff weight to £70,000, based on an empty weight of £39,000. That left margin for the crew £23,000 of fuel and 6 missiles. By 1963, the estimated empty weight had already gone up by £6,000 to £45,000, resulting in an urgent weight reduction program called the Super Weight Improvement Program that began in January 1964. This successfully identified £4,000 of weight savings, all of which were then added back in through other specification changes and engineering realizations. Some areas that were ruled to be unacceptable during the SWIP would later be just fine in the F-14. Removing the crew escape module would save over £2,500, as would reducing the loiter time, going down to 4 Phoenixes as the standard load rather than 6, and reducing the 7.3 G structural limit requirement to 6.5 G. After all this effort, by March 1965, the projected empty weight was up to £46,000, and in cap configuration armed with 6 missiles, it would tip the scales at £77,500. Even at this weight, though, the least powerful catapult that the Navy had could launch it with only 11 knots of wind over the deck, even if the F-111 was using military power only. It could recover the aircraft at up to £62,000 landing weight, although in that state 25 knots of wind over the deck would be required. Stall speed was just 100 knots, 20 knots lower than for an F-4B at its recommended weight for landing. Despite the apparently decent carrier suitability of the F-111B even in the early stages of development, the Navy chose to make a lot of the design's problems. As well as weight, which actually wasn't much of an issue because of the variable sweep wing, shore-based testing showed that deck handling wasn't good. In particular, the aircraft tended to tip backwards onto its tail skid when it was parked. Given that carrier aircraft are often parked at the deck edge, this was a bit of an issue. This was the main reason behind the nose extension, which was introduced on the fourth and subsequent prototypes. The main landing gear was also shifted back 8 inches. Land-based testing also showed that although approach speed and stall speed were excellent, the TF-30 wasn't responsive enough if the pilot needed to bolter. An 8% more powerful version of the engine would have cured that in production models. As always, there were tweaks to be made. The pilot's seat needed to go up 4 inches, the windscreen needed to be tipped back to 30 degrees to improve visibility, and so on. Again, this sort of thing needed to be done on all carrier aircraft at this stage of development. In the end, when an F-111B was carrier qualified in 1968 aboard the Coral Sea, it performed flawlessly. That was all in the future. As 1965 came around, the Navy found itself involved in another war that didn't fit the model it was prepared for. F-4Bs found themselves engaging in visual range fights with MiG-17s. This accelerated the Navy's plans to develop a replacement for the F-4 as an air superiority, strike escort, and general strike aircraft under a program called VFAX. Conceptually, the VFAX aircraft would serve alongside F-111B on carriers, with the latter reserved for fleet defense. VFAX's principal armament was to be an improved Sparrow. Grumman started work on its VFAX in 1966. Even so, the Navy was outwardly committed to the F-111B. Many admirals considered the Phoenix to be essential for fleet defense against the Soviets. and a 1966 study demonstrated that the F-111B was the best option for fleet defense from a cost, deck space, and effectiveness perspective. That assessment included various alternatives, including a Phoenix Arm version of VFAX. That would eventually become the VFX. But behind the scenes, revolt was brewing. Early assessment of the F-4's combat performance in the ongoing Rolling Thunder campaign focused on the relative ineffectiveness of Sparrow and Sidewinder compared to the designer's expectations. It also suggested that the lack of an internal gun was a significant handicap. The later Alt report would validate the problems with missile systems, but point to pilot training as a bigger issue than the lack of a gun system. Even so, a mounting belief in the naval aviation community was that even when armed with Sparrow, the F-111 would be little better than the Phantom, and it could well be worse. Grumman already appeared to be hedging their bets. Even though there was an ongoing effort to reduce the F-111B's weight, amusingly known as the Colossal Weight Reduction Program, by 1967, Grumman had come to the Navy with a version of the VFX that sat somewhere between the F-4 and the F-111 in terms of size and interception capability. Hughes were also slipping their schedule on Phoenix and the AWG-9, meaning that the promised long-range interception capability might well not appear until the early 1970s, leaving the Navy with large and largely useless aircraft. In 1968, it all came to a head. The Navy had to commit to production of the F-111B. Cost per aircraft had grown from $3 million to $8 million. That's $72.5 million today. They were supposed to be committing to 705 aircraft, which adds up to a mighty sum of money. Up to this point, the Air Force had actually paid for everything except the TF-30 and the AWG-9, which the Navy wanted anyway. McNamara wanted them to commit to it, but he then resigned in February. Many in the Navy had simply never wanted the aircraft, and most certainly didn't want it now, when F-4s were still being shot down by MiGs in Vietnam. Furthermore, the program represented a threat to the Navy's autonomy in terms of procurement. Cancelling it would be politically challenging, though. Many people in important states wanted the jobs and they wanted the money. At this moment of need, a champion appeared in the form of Vice Admiral Thomas Connolly. A World War II attack pilot who had flown 39 different types of aircraft in his aviation career, he was an immensely credible figure, and he was thus sent to appear in front of the Senate Armed Services Committee in March 1968 to answer questions on the F-111B. The Navy had already been able to plant leading questions for Senator John Stennis to ask, making the outcome even more of an inevitability. After the initial basic questions were done with, Stennis asked Admiral Connolly whether he personally would prefer to have the F-111B or a new fighter. Connolly answered he would prefer the latter. He was then asked a follow-up question about the TF-30 and whether improvements to the power plant could change his answer. There isn't enough thrust in all of Christendom to make that airplane a fighter, came the salty reply. Congress terminated the F-111B program in July 1968, although several of the aircraft continued flying, with carrier testing only being completed in September of that year. It's easy to start out on the F-111B story with a view of what were they thinking. A Swiss Army knife of an aircraft with such a diverse set of missions was simply never going to work. I think it's sensible in these situations to actually start from the end. The proposed production F-111B was a well-resolved aircraft that could reliably come aboard ship. It was faster than the F-4 and it had well over double the loiter time. But there were still two sticking points. Although the TF-30 situation was improving, in truth it remained an unreliable engine that would frequently compressor stall, even in level flight and at modest speeds. Although it generally restarted just fine, it wasn't really very ideal. More concerning were the ongoing issues with the AWG-9 and the Phoenix. Hughes simply couldn't give any guarantees about when it was going to be ready, despite extensive and expensive testing. In fact, the first 6-on-6 trial engagement by an aircraft using Phoenix only happened after the F-14 had entered service in 1974. Being objective for a moment, two of the main items that the F-14 eventually carried over from the F-111 were the engines and their radar missile combination. The other was the variable sweep wing. The F-14 was certainly a better fighter at close quarters than the F-111B, mainly because it had fighter-and-fighter engagement in its design specifications. It also used a twin tail to get around the F-111's fuselage blanking issues, amongst other things. But it was still a heavy fighter. It weighed 40,000 pounds empty and as much as 72,000 with a full load of Phoenixes and tanks. It carried 16,200 pounds of internal fuel against 23,000 for the F-111B, and the F-111B was still lugging around that escape pod. Some people point to the F-14's gun, Sidewinder, and Sparrow as an advantage in most engagements, but the likelihood is that the F-111 would have had missiles integrated. It could carry a gun if required, although I don't think the B model ever flew with one in testing. Would the F-111 have been a better fleet air defense aircraft than the F-14? Well, the answer has to be nuanced. In the very narrow case of defending against an attack from a regiment of Badgers or backfires, then the answer is probably yes, for the simple reason that the F-111 can operate further from the carrier, loiter for longer, and get there faster. But that's an edge case. The F-14 benefited from all of the aerodynamic and airframe construction lessons that Grumman had learned with the F-111. It also wasn't interfered with by McNamara, and therefore Grumman were free to take technical risks in the use of titanium in greater quantity, hence it was lighter in most conditions. The slightly smaller footprint meant that it was also easier to handle on deck. Could the Navy have operated both types? Well, sure, but honestly, what would have been the point? Carrier decks featured all sorts of oddities in the 1960s, and the Navy needed to rationalize types. The F-14 was still excellent as a mass bomber killer. It's possibly the best aircraft there's ever been for that mission, and it could do every air-to-air mission the Phantom could do just as well or better. Could the F-111 have performed a secondary recon or nuclear strike role? Absolutely yes. But the Navy already had the Vigilante if it wanted a specialized single-mission aircraft. Why spend all that money? The Intruder was also entering service en masse in the late 1960s, and that filled the strike role, albeit in a slightly different manner. So although the F-111B would have been a good aircraft and done a job for the Navy, it wasn't the aircraft they needed as they moved from a deck packed with a potpourri of specialist types to a more rational and more flexible air group. Ultimately, the F-14 itself would succumb to that concept. But that is another story.